Hello everyone. I have announced the results of assignment 1, so you can take a look at our course website to see the accuracy of your assignment 1. And the common mistake is that many students do not follow the requirements specified in assignment 1. So I use the code -2 to mean wrong output format. And here, wrong output format means the outputs of your program does not meet the requirements specified in assignment 1, and you should take a close look at the descriptions of assignment 1. And the outputs of your program should be exactly the same as those in the input-output samples. And here, exactly the same means every output character, including space, new line, punctuation, and letters of your program should be identical to those in the input-output samples. And you can click this link to see the input-output samples. So every letter or space or punctuation should be identical to this example. So if your output is wrong, then you should see the descriptions of assignment 1. And I also post the results of quiz, and you can take a look at this file. And in each week we will have a quiz, and the quiz will have 3 questions. Each question is worth 25 points. And the attendance is also worth 25 points. So the total points of a quiz are 100. And if you have any problem about the quiz results, then you can write email to me. And this week we will continue the chapter flow of control, and we will talk about flow of control of the C++ programming language. And the first part is Boolean expression. And because Boolean expression will be used in the if-else statement and the for-while, do-while statements, so we will introduce Boolean expressions first. And a Boolean expression is a special expression. Recall that an expression is some operations that yield a value. And a Boolean expression is an expression that yields a Boolean value. The Boolean value is either true or false. Here, true and false are constants. And true means integer 1, while false means integer 0. And below is one example of Boolean expression. For example, A is greater than B. This is an example of Boolean expressions. And this expression will yield a value. The value is either true or false. And then this value is assigned to the variable result. Result is a Boolean variable. And in this slide, there are two types of operators related to Boolean expressions. And the first type is comparison operators. The comparison operators include less than or equal to, greater than or equal to, and also equal to. And here, the equal to is two consecutive equality sign. And the two consecutive equality sign is means one operator. This is the equal to operator. And the other one is not equal to. And not equal to is the exclamation symbol. This symbol is called exclamation symbol. And the exclamation followed by the equality sign. The two symbols is the not equal to operator. And the 6 comparison operators can be used to in Boolean expressions. And the other type is the logical operators. The logical operators including 3 operators: and, or, and not. And next, let's see the logical operators. And let's see the AND operator first. AND is a binary operator. And here, binary means this operator has 2 inputs. Just like we perform addition, the addition operator is a binary operator because the addition has 2 inputs. So here, AND and OR are binary operators because they have 2 inputs. And suppose the inputs are denoted by expression 1 and expression 2. And each expression is a Boolean expression. So expression 1 is either true or false. And expression 2 is also a Boolean expression. So its value is also true or false. And this table lists all the combinations of expression 1 and expression 2. And there are 4 combinations. There are 4 possibilities. And the result of AND operator is shown in the 3rd column. And let's see the results. Let's see the output of the AND operator. If either expression 1 or if any one of the two inputs is false, then the output is false. You see that this row expression 2 is false, so the output is false. And in this row, expression 1 is false, and the output of AND operator is false. And if both expression 1 and expression 2 are false, the output of the AND operator is also false. So if any one of the two expressions is false, then the output of the AND operator is false. And if both of the expressions are true, then the output of the AND operator is true. Next, let's see the OR operator. OR is also a binary operator, and the binary operator has two inputs, and both inputs are Boolean expressions. So expression 1 is either true or false, and expression 2 is also true or false. And this table lists all the possibilities. And if any of the expression is true, then the output of the OR operator will be true. For example, in this row, both expressions are true, so the output of the OR operator is true. And in this row, the expression 1 is true, and the output of the OR operator is true. And in this row, expression 2 is true, so the output of the OR operator is true. So in summary, if any of the two expressions is true, then the output of the OR operator is true. And if both expressions are false, then the OR operator will output false. And the third operator in the logical operators is the NOT operator. And this operator is called an unary operator. An unary operator means this operator has only single input. So the NOT operator only has one input. And the input is also a Boolean expression. The Boolean expression is either true or false. And the second column denotes the output of the NOT operator. And here, NOT means to invert the input. So if the input is true, then the output of NOT is false. If the input is false, then the output of the NOT operator is true. So the NOT operator is to invert its input. Next, we see some examples of Boolean expressions, and this example is related to the precedence of operators. And let's consider this example. This is an expression, And let's count how many operators are there in this expression. And in this expression, there are 6 operators. The plus operator, the greater than operator, and the or operator, the plus operator, and the less than operator, and this one is the negative sign. So in this expression, we have 6 operators. And when the compiler sees this expression, the compiler need to determine which operator will be carried out first. So we need to check the precedence of operators. We need to know which operator will be carried out first. And the compiler will determine the precedence by the following table. And if the operator is in the upper part of the table, then this means the operator will have higher precedence. If the operator is in lower part of the table, then this operator will have lower precedence. And let's see this example. For example, the plus operator will be in which place of the table, the plus operator. And if you check this table, you will find there are 2 plus symbols in this table. The first one is the unary plus, and the second one is the addition plus. So we need to determine the plus is in the first row or in the second row. We need to determine this plus is an unary plus or an addition operator. And clearly, in this example, the plus is the addition operator, because this plus has 2 inputs. The inputs are x and 1. So this plus is a binary operator, and x plus 1 means we perform addition. So the first plus means addition, and the unary plus means the unary plus means plus is the unary operator. The unary operator has only single input. So the unary plus is like plus 1, plus 2. The unary plus is used to denote the sign of a number. So the first plus is the addition operator, and the addition operator is in the third row of this table. And let's see the greater than operator, and this operator is in the fourth row of this table. So according to this table, plus is of higher precedence than the the greater than operator. So the compiler first will evaluate x plus 1 first, because x plus 1 is of higher precedence than the greater than operator. And let's see other operators. For example, let's see this operator. And if you check the table, you will find this symbol, the negative symbol, will appear in the table in the first row and in the third row. And we need to determine this minus sign is in the first row or in the third row. And in the third row, the negative sign means subtraction. And the subtraction is a binary operator, because if we want to perform subtraction, we need two numbers. So subtraction is a binary operator. And whereas the unary minus is the unary operator. Unary operator means it has only single input. And the unary minus is used to denote the sign of a number. So here, -3, and here the negative symbol is in the first row, is the unary minus. And the unary minus is of the highest precedence, because it is in the first row of the table. So unary minus is of the highest precedence. This means the -3 will be evaluated by the compiler first. So when the compiler sees the 6 operators, so when the compiler sees the 6 operators, the compiler will evaluate the unary minus first, because the unary minus is of the highest precedence. And then the compiler will evaluate the plus operator, because in this example, the second highest precedence is the addition operator. And then the compiler will evaluate the comparison operator, the less than and the greater than operator. And finally, the compiler will evaluate the OR operator, because the OR operator is of the lowest precedence in this example. So in this example, the compiler will first evaluate -3, then evaluate x plus 1, and then x plus 1. And then the compiler will evaluate the result of x plus 1 and compare this value with 2. And then the compiler will evaluate will compare the value of x plus 1 and -3. And this comparison operator will yield a Boolean value. And finally, the compiler will use the OR operator to evaluate the two inputs. So the final output of this expression is the output of the OR operator. So if we want to if we want to determine which operator will be carried out first, we need to check the precedence. We need to check the table of precedence. And in this slide, the textbook point out a common mistake that is related to logical operator. For example, consider the expression, the exclamation symbol, followed by a parenthesis. And inside the parenthesis is the expression time is greater than limit. And let's consider this expression. If we omit, let's see if we omit the parenthesis, then what will happen? And if we omit this parenthesis, then the expression becomes this one. And in this expression, we have two operators. The not, this is the not logical operator, and the greater than operator. And if you check the precedence table, you will find the not operator is of higher precedence than the greater than operator. So in this example, the compiler will evaluate not time first, because the not operator is of higher precedence than the greater than operator. So compiler will evaluate not time first. And this is equivalent to you add a parenthesis around the not time. And let's see what happens if we evaluate not time first. This is a Boolean expression. Not time is a Boolean expression, and the Boolean expression will yield either true or false. So this expression will become true is greater than limit, or false is greater than limit. But this is not what we want. Our intention is to compare time, the variable time and the variable limit. Our intention is not to compare true with limit or compare false with limit. This is not our intention. Our intention is to compare the value of time with the value of limit, and then we invert the result of the comparison operator. So if we omit the parenthesis, if we omit the parenthesis like this one, then the results of the expression will be different. And so this is a semantic error, because this is the syntax is legal, but this expression is not does not conform to our intention. So this type of error is a semantic error. So when we want to use the not operator, when we want to use the not logical operator, and you need to pay attention that whether you should add a parenthesis after the not operator. And in fact, this expression, not parenthesis, inside the parenthesis is time is greater than limit. You can rewrite this expression as the expression in the bottom of this slide. And this expression is equivalent to time is less than or equal to limit. The two expressions are the same. The two expressions have the same effect, and they are equivalent. And my suggestion is that when you write programs, you should avoid using write programs in this way, because using the not operator will makes your program hard to read, and because you need to because the button expression is more easy. It's easier to understand. We simply compare the value of time and the limit. But if you write your program in this way, you need to compare time and the limit, and then invert the results. So the first expression is less direct, and is more difficult to understand. And when writing programs, we should make our program as clean as possible. So we should avoid using the not operator. But when you see the other people's program, you need to understand the semantic of you need to understand the semantic of other people's program. So you need to understand the syntax of the not operator. And next, let's see another common mistake. And this common mistake is about the use of the inequalities. For example, if we want to this common mistake is about strings of inequalities. And here, string is not the data type string. String means a lot, many inequalities. So if we want to evaluate this mathematical expression, and this mathematical expression has two inequalities. Sx is less than z, and z is less than y. We suppose we want to evaluate this mathematical expression, and we cannot directly write this expression in C++, because this expression in C++ means the following. There are two operators in this expression, and the two operators are the same. So the compiler will evaluate the left operator first. So the compiler will compute x is less than z first, and x is less than z is a Boolean expression, so its value is either 1 or 0, or you can say true or false. So this expression will become 1 is less than y, or 0 is less than y. And this is not what we want. Our intention is to compare z with y. Our intention is not to compare 1 with y or compare 0 with y. So this expression is not what we want. This expression is legal. The syntax is legal in C++, but the semantic of this expression is wrong, because the semantic is equivalent to 1 is less than y, or 0 is less than y, and this is not what we expect. And to correctly represent this mathematical expression, we need to use the bottom expression, and we need to compare x and z, and compare z with y, and then we need to use the logical AND operator to evaluate the two Boolean expressions. So if we want to perform x is less than z and z is less than y, then in the C++ programming language, we need to write the expression as in the bottom line of this slide. And you can omit the parentheses, because the greater than or the less than operator is of higher precedence than the AND operator. So in this expression, you can omit the parentheses, because the greater than, the less than operator is of higher precedence than the logical AND operator. And next, this slide is also related to the AND, or is related to the AND operator. And I will skip this slide. And if you are interested, you can look the description in the textbook. And I will also skip this slide. This slide introduces the enumeration type. It is another data type in the C++ programming language. But due to time insufficiency, so I will skip this slide. And next, let's see the if-else statement. And in our previous program, the program will execute each statement line by line from top to the bottom. But sometimes we want to branch, we want to skip some block of statements. And in this scenario, we need to use the if-else statement. This statement allows us to branch, allows us to skip some blocks of statements. And let's see the syntax of the if-else statement. And if is the keyword in C++, and if is followed by a parenthesis, and inside the parenthesis is a Boolean expression. And if the Boolean expression is true, then the compiler will execute the yes statement. If the Boolean expression is false, then the compiler will execute the no statement. The no statement is under the else keyword. So here, if and else are keywords in C++. And let's see an example. For example, we want to compare the variable hours. We want to know whether hours is greater than 40. And if this is true, then compiler will execute this statement. If hours is not greater than 40, then compiler will execute the statement under the else keyword. And in this example, the yes statement only has only one statement. If you have multiple statements, then we need to use the so-called compound statements. And so if you have more statements, you have multiple statements, you need to add a brace around your statements. So if you have two statements, then you need to add braces around the statements. So in this example, the yes statements has two statements, and we need to add braces around the two statements. And similarly, the else has two statements, so we need to add braces. And this is the basic syntax of the if-else statement. And let's take a break for 10 minutes. Hello, let's continue our class. And if the accuracy of your assignment is not 100, you can resend your assignment, and the deadline is October 25. And you can also see the syllabus in the course website, and I will, if you send your assignments before October 25, you can improve the accuracy of your assignment 1. And next, we will have a quiz. So we will have a quiz, and raise your hand if you cannot use the Rubio app. If you cannot use the Rubio app. And if you cannot use the Rubio app, I will give you the paper. I have not opened a question. I need to open a question, then you can see. And the first question is to select the illegal statements. And you cannot use laptop computers or tablet. So if you have laptop computers, you need to close your laptop computers. And you can see the slides in the previous lecture. And you have 2 minutes to answer this question. And I will close this question, and you have 5 seconds. After 5 seconds, I will close this question. And the next question is, you need to determine the value of VAR3. And VAR1 is an integer with the initial value 11. VAR2 is an integer with the initial value 3.0. And below is the statement about VAR3. You need to determine the value of VAR3. And you have 2 minutes to finish this question. And 10 seconds left. I will close this question. And the third question is about the size range of data types. And you need to determine the size range. You need to compare the size range of 3 data types: unsigned int 64, and unsigned int 32, and float. You need to compare the size range of the 3 data types. What? The size range means the. Yes, yes, you can check the slides, previous slides. Uh, 30 seconds left. So I will close this question. And I will collect the papers. So if you write down your answers on the paper, and remember to write your name and your student ID. And okay. And let's see the answers. And for the first question, the illegal statement is the third one. So, and most people choose the correct answer. And the first one is correct. 2E3 is scientific notation, and this is correct syntax. And the second one is also correct syntax. The fourth line, and it is legal to use empty string. This string does not include any character, and this is legal. This is legal C++ syntax. And the third line is not legal. It's illegal because because this line does not have an ending double quote. Because the double quote, you see that the string must be enclosed in double quotes, and in this example, the backslash double quote means a character, and so in this example, we do not have an ending double quote, and you can try to type this line in the compiler, and you will find this is a syntax error. And the next question, the correct answer is 9. So the first choice is correct, and many of you select 11, and I will explain why the correct answer is 9. And VAR1 is an integer, and VAR2 is also an integer. So VAR1 divided by VAR2 is integer division. So don't confuse with the 3.0, because we need to you need to determine this division is integer division or floating point division, and you need to check the data type of VAR1 and VAR2. And for this question, the data types of VAR1 and VAR2 are both integer. So here, the division is integer division. So 11 is divided by 3, not 3.0. So after the integer division, the result is 3. 3 times 3. So the result of VAR3 is 9. And you can also write a simple program to test the results. And let's see the third question. And in this question, you have to determine the size range of the 3 data types. And the correct answer is the first one. And the unsigned int 64 is 8 bytes, and the unsigned int 32 is 4 bytes. And the float data type is 4 bytes. And we cannot use the size of the memory to determine the size range, because float and unsigned int use different ways to store the values. So even the float has only 4 bytes, but the size range of float is larger than the size range of unsigned int 64. And you can check the table. you can check the table of it in the previous slides. The size range of float is 10 raised to power negative 38 to 10 raised to power 38, and this is larger than unsigned int 64. And you can, for example, you can compute this by, so 10 raised to power 64 is approximately of this value, and while the float, the maximum value of float is 10 raised to 38. So the size range of float, is larger than unsigned int 64. And because float use different ways to store, to represent numerical values. So although the memory size of float is smaller than the memory size of unsigned int 64, but the size range of float is larger than unsigned int 64. So for this question, the correct answer is the first one. And you don't need to memorize this number, but you need to have the understanding that, for example, you need to know how to compute the size range of integer data types. In previous lectures, I have shown how to determine the size range of integer data types. And our quiz, for our quiz, you cannot use laptop computers, but you can use mobile phone to see the previous slides. But you are not allowed to use laptop computers because for fairness. And our midterm exam is pencil and paper. It is closed book. You cannot use computer or mobile phone or bring any data. So our midterm and the final exam will be pencil and paper test. So you need to learn how to run the program in your mind. And in the quiz of each week, you will have the opportunity to answer the questions. So in the midterm exam, the questions will be similar to those in the quiz. I will write some statements, and after after these statements, you need to determine the value of one variable. So our midterm and the final exam will have questions of this type. And let's return to our slides. And we have learned the syntax of the if-else statements. And below are some common mistakes of using the if-else statements. One common mistake is to use the equality sign in place of the equality operator. If the single the single equality sign means assignment, while the two consecutive equality sign means comparison. These two are different operators. For example, if we want to compare x with 12, but we miss one equality sign, so we write in this way. And then this is legal syntax, so the compiler will not issue any error. But the semantic of this expression is not what we want. And let's see what happened. And you can use you can write some simple program to test the examples in the slides. And for example, you can use the online IDE. For example, we can use the online IDE. For example, I declare a variable x, and its initial value is 11. And suppose I want to compare the value of x with 12. I want to compare the value of x to 12. And if this is true, then the compiler will print yes. Otherwise, the computer will print no. And if you can compile and run this example. And we see that the program outputs no, because the initial value of x is not equal to 12. But if we miss one equality sign, and let's see what will happen. And in this time, the program outputs yes. And this is not what we want, because we want to compare x with 12. So what happened in this expression? In this expression, we perform an assignment. We assign 12 to x, and the assignment operator will yield a value. So after this assignment, this assignment will yield a value 12. And you might wonder that 12 is not a Boolean expression. You might wonder, because inside the parentheses should be a Boolean expression. But in the C++ programming language, integer can be used to denote Boolean expression. If this value is not 0, then it will be treated as true. So 12 will be treated as true, and therefore the program will always output yes. So if you write your expression in this way, the program always outputs yes, regardless the initial value of x. And for example, you can change other value. The output will always yes. But if you assign 0, if you assign 0 to x, then the Boolean expression is false. So the program always outputs no. So let's see the output of this example. If we assign 0 to x, then the value of this expression is 0. And C++ treats 0 as false. So the Boolean expression is false, and the program will output no. And this type of mistake is hard to find, because its syntax is legal. The compiler will not find this type of mistake. But so this type of error is a semantic error, because it is the syntax is legal, but the expression is not what we want. And the textbook suggests that we use if we want to compare x with 12, then we can write in this way. And for example, if we want to compare x, we want to compare 12 with x, we can write in this way. And let's see the program outputs. The program outputs no, because the initial value of x is 9. And in this time, if we omit one equality sign, then let's see what will happen. In this time, the compiler can detect the error, because in this is an assignment, and for an assignment, the left-hand side operator needs to be a variable. But on the left-hand side is a constant, so the compiler will issue an error. The error message is L value required as the left operand of the assignment. because on the left-hand side of the assignment, L value is a variable, but for this expression, the L value is a constant. So this is syntax error. So the textbook suggests if we want to compare a variable with a constant, we can write the constant on the left-hand side. Then in this way, the compiler can detect this type of error if we omit one equality sign. Then if we omit one equality operator, then the compiler can detect this type of error. So when we want to compare x with, or if we want to compare x with some constant, if you omit one equality symbol, then this is syntax. The syntax is legal, but the semantic is not what we want. And next, in this slide, it shows another example. In this example, we can omit the else statement. So the else statement is not necessary. If your program does not have an else part, then you can omit the else part. And another common mistake about using the if statements is to forget inserting braces. And we can copy the source code of this example to the compiler. And in this example, I declare two variables, my score, and the initial value is 5. And I also declare another variable, your score, and its initial value is 10. And in the if statement, we compare my score with your score. And if this is true, then the compiler will execute I win. Then let's see the program output. Because my score is not greater than your score, so the program will not output I win. And I also print the value of the variable wager. And you can see the value of wager is 150, not 50. Because if this means this line is executed. because the initial value of wager is 50, then after we add 100 to wager, then the value of wager becomes 150. So this means this line is executed, but you might find but my score is not greater than your score. So you might think this line shouldn't be executed because my score is not greater than your score, and so the correct syntax is, if we want to include the two lines, we need to add braces around the two statements. And in this time, the value of wager is 50. The wager is 50. It does not enter the yes statement of the if statement. But if you omit the brace, then this line is the correct correct indentation is like this. The C++ the indentation does not affect the C++ programming language, so it is legal to remove the spaces, the tabs. So the space and the tabs will not affect the program outputs. The program outputs are the same. And if you want to include two statements, inside the if statement, then you need to use braces. So if we want to include two statements, you need to add braces around the two statements. And if you remove the statements, this means if you remove the statements, then this is equivalent to you only include one statement. So if you omit the braces, then this is equivalent to this block. So we shouldn't be affected by the indentation. We shouldn't be affected by the spaces. If there is no braces, then the if statement will only include one statement. And next, let's see another usage about the if-else statements. And this is called nested if-else. This means inside the if statement, there is another if-else statement. This is called nested. And you can also add statements inside the if statements. So this is called nested if-else statements. For example, in the first if statement, I compare speed with 55. If this is true, then we will enter the if block, and then we will evaluate the expression speed is greater than 80. So the second if is inside the first if statement, and this is called nested if-else statements. And in this slide is another usage about the if-else statement. In the previous example, we only have the if part and the else part, and you can also add many else if part. So besides the if part and the else part, we can add many else if parts between after the if statement. And for this example, we compare temperature with -10, and we check the variable day is equal to Sunday. If both the Boolean expressions are true, then the compiler will print stay home, and the if statement is finished. However, if any of the two expressions is false, then the compiler will continue to check the statements below if. So for example, the temperature is not less than -10, then the compiler will check this statement. Suppose day is not Sunday. Suppose day is not Sunday, and the compiler will continue to check the else if statement. And but the temperature is, suppose the temperature is less than -10, then in this time the program will output stay home but co-work. And then the if else statement finishes. And however, if the temperature is not less than -10, then the compiler will continue goes down. Then the compiler will check the else if part. And if temperature is less than or equal to 0, then the program will output dress warm. And if temperature is less than or equal to 0, then the if else statement is finished. And however, if temperature is not less than or equal to 0, the compiler will go to the else part and output work hard and play hard. So the Boolean expressions are checked in order until the first true Boolean expression is encountered. If there is no true Boolean expressions, then the compiler will execute the else part. And let's take a break for 10 minutes. Hello everyone. Let's continue our class. And and we have finished the if else statement. Next, I will introduce the switch statement. And this statement is similar to the if else statement. This switch statement is also belong to the branching mechanism. And the switch statement allows us to select which block of statement to be executed. And let's see the syntax of the switch statement. And the words in red color means keywords. So here, switch, case, break, and default are keywords in C++. And after the switch is a parenthesis. And inside the parenthesis is a controlling expression. And here, controlling expression means integer value or a character or a Boolean value. So inside the parenthesis, can be a Boolean value, an integer, or a character, or an enumeration constant. But this type is more advanced, so I will skip the enumeration constant. And so the controlling expression is either a Boolean expression or an integer or a character. And after the keyword case will be constant. So there are many cases. So constant 1 corresponds to the first case, and constant 2 corresponds to the second case. If the controlling expression if the controlling expression is not constant 1 or constant 2 or constant 3, then the compiler will execute the default part. And let's see an example. For example, I copy the source code into the online IDE. And let's compile this program. And you can see the error message because I did not declare the variable total. So I need to declare And And for this example, I declare a variable vehicle class. Vehicle class is an integer variable, and its initial value is 1. Then the controlling expression of the switch statement is this integer, is vehicle class. And since the initial value of vehicle class is 1, then the compiler will go to case 1 and execute the statements under case 1. So the compiler will print passenger car, and we will see passenger car printed. And then 0.5 will be assigned to the variable toll. And then this statement break will terminate the switch statement. So when the compiler sees the break statement, then the switch statement is terminated. So the compiler will not execute this block of code. And I also print the value of toll after the switch statement. And we can see that after the switch statement, the value of toll is 0.5, because inside case 1, I assign 0.5 to toll. And it is a good habit to give initial value to variables. For example, if I change the initial value from 1 to 2, and let's see the output of the program. And in this time, the program outputs bus, because vehicle class is 2. Then the compiler goes to case 2 and print bus, and assign 1.5 to the toll variable. So after the switch statement, the compiler prints toll is 1.5. And if we assign 3 to vehicle class, and let's see what happened. And for this time, the program outputs unknown vehicle class. And because vehicle class is not case 1, not case 2, so the compiler goes to default and print unknown vehicle class. And we did not assign any value of toll. So the toll of value does not change. So the value of toll is its initial value 0. So after the switch statement, the value of toll is 0. And a common mistake about the switch statement is to forget the break statement. If we omit the break statement, then there will be no compile error. It is legal to omit the break statement. And let's see what happens if we omit the break statement. For example, if I assign 1 as the initial value of the vehicle class, and then I delete the break statement, and let's see what happened. And in this time, the vehicle class is 1. So the initial value of vehicle class is 1. So the compiler will go to case 1 and print passenger car and assign 0.5 to the variable toll. But we delete the break statement. So the switch statement will not terminate. The compiler will continue case 2. So the program will output bus and then assign 1.5 to toll. So the value of toll becomes 1.5. Then this break statement will terminate the switch statement. So after the switch statement, the value of toll is 1.5. If we also delete this break statement, and let's see what happened. And in this time, the compiler will print. The program will print passenger car and print bus and print unknown vehicle class, because there is no break statement to terminate the switch statement. So the compiler, if there is no break statement, the compiler will execute every case of the switch inside the switch statement. And after the switch statement, the value of toll is 1.5 because of this statement. And you can use this example to enhance your understanding of the switch statement. So the break statement is not necessary, and it depends on scenarios. Sometimes you need a break statement, and for some scenario you don't need the break statement. And the switch statement is often used for menus. For example, case 1 means menu 1, and case 2. For example, I click this menu, and inside this menu has many options. The first option is open, and you can. So open corresponds to case 1, and the second option is build. So build corresponds to case 2, and the third option is save, and save corresponds to another case. And you can also add a default case. So the switch statement is can be used to define a menu, and the menu provides us a big picture view. And you can also add another switch statement inside a case. For example, you can use in statement sequence 1, you can inside another switch, and this is called a nested switch statement. And it is like you click this menu, and inside this menu you also have another sub menu, and inside the sub menu you can have another sub menu. And this in this slide, we this example illustrate that sometimes you can omit the break statement. For example, you want two cases to share the same statement, and in this time you can omit the break statement. For example, we return to this example. For example, we can let case 2 and case 3 share the same. Suppose we want case 2 and case 3 to share the same statement, and let's consider an example. In this example, case 2, the statement for case 2 and the statements for case 3 are the same. The statements for case 2 and the statements for case 3 are the same. And let's compile. For example, I let the initial value of vehicle class 2 is 2. Of vehicle class is 2, and then I forgot to add a semicolon. So the program outputs sometimes the output. So the program outputs bus because the initial value of vehicle class is 2. And the value of toll is 1.5. And if I change the value of from 2 to 3, then the output of the program are the same. And because the statements of case 2 and the statements of case 3 are the same. But this is redundant because the two parts are the same. So there is some redundancy, and C++ allows you to share statements between cases. So we can, if we want to share statements between case 2 and case 3, and you can just delete the statements under case 2. And let's compile the program again. So the output of the programs are the same. And this syntax means if vehicle class is 2, then the compiler will go to case 2. And since there is no break statement, the compiler will continue, goes down, and the compiler will go to the statements under case 3. So we can omit the break statement if we want to share statements. So in this example, uppercase A and lowercase a share the same statements, cout. And next, let's see another operator. This operator is called conditional operator. And this operator is very special. It consisted of a question mark and a column symbol. So the conditional operator consists of the question mark and the column symbol. And this operator is very special because it is a ternary operator. A ternary operator means this operator has 3 inputs. Previously, we haven't seen any ternary operators. The ternary operator has 3 inputs. Let's see one example. Suppose we want to execute the if-else statement. We compare the variable n1 with variable n2. And if this is true, then n1 will be assigned to max. Otherwise, n2 will be assigned to max. And we can rewrite this if-else statement as the right-hand side. We can use the conditional operator. We can use the conditional operator to represent this if-else statement. And the first input of the ternary operator is the Boolean expression. So the first input of the ternary operator is the Boolean expression. N1 is greater than N2. If this Boolean expression is true, then the operator will return the value after the question mark. You replace, you mean, or plus equal, you say, let me see. You cannot. You can only assign values. You cannot assign if this equality sign is replaced by plus equal. You mean yes. If you cannot replace just for this syntax. For the conditional operator, there is no equivalent. If there is no equivalent expression for conditional operators, n plus n1. You can it might be if this equality is plus equal, then this means we assign max plus n1 to max. So you just replace n1 with max plus n1. So if this equality is replaced by plus equal, then you need to replace n1 with max plus n1. And we can use an example to test this syntax. For example, let's compile this. Let's compile this program, and max is 6 because n1 is not greater than n2, so n2 will be assigned to max. And we can use the conditional operator to replace the if-else statement. So the program outputs will be the same. Max is 6. And if you change this equality to plus equal, and let's see what happens. So I changed the initial value of max to 1. So after the if-else statement, max is 7. Because max plus equal to n2, this statement is executed. And this statement means max. This statement means max plus n2 is assigned to max. So if we change the equality symbol to plus equal, then the statement is the same as this one. And if you still want to use the conditional operator, then you need to modify the corresponding part like this. And you see that the program outputs are the same as the if-else statement. You mean plus? You mean this? If I replace this plus with plus equal. And okay, we can try. You mean this part? And I think one is. I think the result is the same. It's still 7. If you assign because this is equivalent to you assign. This is if you change equal to plus equal, then this is equivalent to you you perform max plus and the max plus this expression, then assigned to this value to max. If you change the sorry. 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 Okay. You mean this? Yes, but you need to first to change to this expression. You need to change. The two statements are equivalent. You need to change this equation to this one. And if this expression is to replace this value with is the value after the question mark. So if you really want to use plus equal, then you first you need to, or you can type the code here. You can type the code here. Oh, okay. And it is not necessary to use this operator. And you can always use the if-else statement. So it is not necessary to use this conditional operator. Sometimes it is convenient to use this conditional operator for very simple statements. For very simple if-else statements, we can use conditional operator to replace very simple if-else statements. But if your if-else statements are very complicated, you can then I do not suggest you use conditional operator, because this will make your program hard to read. And next, let's go to the third part. We will introduce the loops mechanism. And loops means you execute the statements over and over. And there are 3 ways in C++ to write. And there are 3 ways in C++ to write loops. The first way is while, and the second way is do while. The third way is for. And let's see the while statement. The syntax for the while statement is like this. And while is the keyword. And after the while is a parenthesis. And inside the parenthesis is a Boolean expression. If this Boolean expression is true, then the compiler will execute the body statement. And I draw a figure for the while loop. The compiler will first check the Boolean expression. And the Boolean expression is either true or false. So if the Boolean expression is true, then the compiler will execute the body statement. And after the body statement is executed, then the compiler will check the Boolean expression again. So the compiler checks the Boolean expression again. And because the Boolean expression might change, and if the Boolean expression is true, then the loop will continue. But if the Boolean expression is false, then this while loop terminates. And let's see one example for the while statement. And for example, if we declare a variable count, suppose the initial value of count is 0. And the Boolean expression is count is less than 3. And if the Boolean expression is true, the body statements will be executed. And we see that the body statement will add 1 to the variable count. So each time this statement is executed, the value of count will be increased by 1. And then the compiler will check the Boolean expression again to see whether the value of count is less than 3. If this is true, if the value of count is less than 3, then you will continue execute the body statement. If the value of count is greater than or equal to 3, then the while statement terminates. And for this example, we can count how many times the loop body executes. For this example, how many times the loop body executes. And let's see. And for this example, the initial value of count is 0. So count is less than 3, and then program will output high, and then the value of count is increased by 1. So the loop body executes for the first time. Then the compiler goes to the Boolean expression again. Here, count, the value of count is 1, and the 1 is less than 3. Then the program outputs high and increase count by 1. And then this time, the value of count is 2, and the 2 is still less than 3. And the program outputs high again and increase count by 1. So when the value of count is 3, then this Boolean expression becomes false because 3 is not less than 3. So when the value of count is 3, the Boolean expression becomes false, and the while statement terminates. So the loop body executes 3 times. You can count by yourself, or you can use a website to help you understand the flow of the while statement. And there is a reference web page, the REF. You click this link, and below are some references. And for the flow of control, you can click the C++ tutor. And we can use this website to visualize the flow of the program. But it takes some time to wait the for example, this time we are at int count 0, and you click next, and the compiler check whether count is less than 3, and if this is true, then the compiler will enter the loop body, and this will increase the value of count by 1, and you notice the value of the count, the value stored by count. If I click next, you see the value of count is increased by 1 because this statement is executed. And then the compiler goes to the Boolean expression again and evaluates the Boolean expression count is less than 3. And if this is true, then the compiler goes to count plus. And after this line is executed, we know that the value of count will be increased by 1. So if I click next, you know that the value of count is increased by 1. And then the compiler will check whether count is less than 3. If this is true, it continues to execute this line. And when the value of count is 3, then this Boolean expression becomes false. So when I click next, the while statement terminates, and it will execute the return 0. And you can use this website to understand the flow of the while statement. And time is up, so let's end here. Sorry, we need to take a picture. We need to take a picture for the policy of COVID-19.